Okay. Okay, we'll start. A very good afternoon to all. Uh, so we have completed so far in module number 3, hydraulic jump. We have completed. I hope this syllabus is visible to you all, right?
Yes.
So in module number 3, we have completed hydraulic jump, expression for conjugate depths, energy loss equation, then numerical problems on gradually varied flow, then the equation, even backwater curve and afflux we have discussed, and even uh, the problems on this backwater curve we have solved. Okay, so that is a dy by dx. If it is coming 0, that is a uniform flow. If it is greater than 0, it is a what we call as a what is that, drawdown or afflux rising. What you get if dy by dx equal to greater than 0? What kind of profile you get? Backwater curve. If dy by dx is less than 0, what you get? What kind of profile you get?
Drop down curve.
Drop down or drawdown. Okay. Then if dy by dx is equal to 0, then what you get? If suppose dy by dx equal to 0,
Uniform flow.
uniform flow. Okay. So that we have seen in a gradually varying flow equation. And the left out portion is a description of water curves or the profiles: mild, steep, critical, horizontal, and adverse flow profiles. Then the numerical problems on identifying the flow profiles. Okay, about these we'll discuss in today's class. And for your internals, these two modules will be there for internals. Okay, so let us discuss about the description of water curves or the profiles. Now this slide is visible to you all, right?
Yes.
Right. Okay. So we have already discussed about the flow classification. In an open channel, there are two types of flows we generally come across. One is a steady and another one is unsteady. Again, in a steady, we can classify the steady uniform or a steady non-uniform like this. Again, in unsteady, gradually varied flow and rapidly varied flow. So these gradually and rapidly again will come in non-uniform flow also. That is a gradually varied flow and rapidly varied flow. As we are discussing about the non-uniform flow, this type of flow. 1 minute. Okay, so this we are discussing non-uniform flow. So already we know the definition of uniform flow. Uniform flow means the depth is constant at every section along the length of the channel, and non-uniform flow means, or the varied flow means, the depth changes along the length of the channel. So in that non-uniform flow, again rapidly varied flow, that is the depth changes suddenly, and gradually varied flow, the depth changes gradually. Okay, so this already we have discussed. That is, a flow is said to be gradually varied when the depth changes gradually over a long distance, whereas in rapidly varied flow, the change in depth takes place in a very short distance. And if flow is gradually varied, the depth y and other flow factors vary smoothly from section to another section. And in varied flow, if you take the depth y and other flow factors change abruptly or suddenly over a very short distance, then in case of a rapidly varied flow, we can notice the discontinuity of a flow. That is, the discontinuity of flow is also possible. Then the rapidly varied flow can seen example at a wear, at a change in the channel width, at an hydraulic jump or an hydraulic drop. Okay, then this is how we get gradually varied flow and rapidly varied flow pattern. So here that's just behind, that is the flow behind the dam, if you take, it will be gradually varying. Then the flow above the crust or the spillway of the dam, it will be rapidly varied. Again we get the gradually varied. Then we get the uniform flow. Then again near the drop we get a gradually varied flow. Then again rapidly varied, again gradually varied. So here RVF or GVF means rapidly varied flow and gradually varied flow. These all things we have seen in previous class, and this is how the examples for gradually varied flow and rapidly varied flow. And so this is how we get gradually varied flow and rapidly varied flow. These all are the examples for gradually varied flow in open channel. I hope these things we have discussed in the previous class, right? How we get gradually varied flow and uniform flow or rapidly varied flow, right? Yes or no? Hello? So about these things we have discussed, right?
Yes, sir.
Okay. So in again we have made certain assumptions for deriving the gradually varied flow equation. That is, the channel is prismatic and flow is steady. The bed slope SO or SB is relatively small. The velocity distribution in the vertical section is uniform, and kinetic energy correction factor is very close to unity, and streamlines are parallel, and the pressure distribution is hydrostatic. The channel roughness is constant along its length and does not depend on the depth of flow. So these all assumptions we have considered while deriving the equation for the gradually varied flow. And the characteristics of gradually varied flow. What are the characteristics of gradually varied flow? The water depth and the velocity change gradually. Flow is non-uniform. Water surface changes smoothly and continuously. Friction loss along the channel is not negligible. And tasks here, you can reduce the trend of water surface change. There is a classification of surface profiles you can make for the gradually varied flow, and also calculate the water levels and velocity along the course of the channel. There is a quantitative evaluation can be done, and the analysis method, you can use the Bernoulli's equation as well as the continuity equation to analyze the flow pattern for the gradually varied flow. And this also we have derived in previous class, and this is the channel. Okay, just I am revising the things what we have discussed so far. So this is the channel bed or the channel bottom, and this is having a slope of 1 horizontal to s vertical. This is the channel slope. And if you take the height of this one as a if since this is the distance between the section 1 and 2, this is section 1 and this is section 2. If you take the distance between these two is taken as a delta x here, and for a, one horizontal, the vertical is SO. Okay, so for delta x horizontal, the vertical will be S into delta x. So here it is mentioned here. And the height of water or the depth of water in the channel at section 1 will be the H1 taken, and H2 will be the height of water or the depth of water at section 2 in a channel. And the free water surface of this channel itself represents, that is free water surface of the channel itself represents the hydraulic gradient line. And at section 1, the depth of water is H1, and above that will be V1 square by 2G. And at section 2, the depth of water is H2, and above it will be the V2 square by 2G, that is a kinetic head. Then from section 1 to 2, if you draw the line, so this line gives you the energy gradient line. Here it is mentioned, and the slope of this energy gradient line here is mentioned as a 1 horizontal to SF vertical. Okay, SF means the slope of energy line. Okay, slope for the energy line. And the head loss is taken as HL equal to S into delta x, the same whatever the distance, the same you will be getting here also, the same. Or you can write it as sf into delta x. For a length of delta x, how much should be the loss, that is s into delta x. Okay. And if you want to write the energy at section 1, it will be written as a, or energy head, it will be written as a v square by 2g plus h plus z as according to the Bernoulli. And as if you differentiate this equation, we get in this format. And here the dh by dx means what? The change in depth of water along the direction of x, along the direction of x, the change in the depth of water, that is represented by the bed slope, that is represented by the bed slope. Why it is taken as a minus here is because it is decreasing along the direction of flow, that is the depth is decreasing along the direction of flow. And even dz by dx is, sorry, the dh by dx is what? Energy gradient, that is energy one. Okay, water surface, that is surface. S is means surface of water, that is changing. And dz by dx is the channel bottom, it is varying along the direction of x. Again, it is taken as a minus, means it is decreasing along the direction of the, along the direction of the flow. And here S equal to SF means slope of energy gradient line. Slope of energy gradient line. I hope these things were discussed previously, right? Hello.
Sir.
We have discussed these things, just I am revising. And again, we have derived this equation in this format, or we have taken as a dy by dx. I hope you are remember this equation, this one. Okay, which was that one? This one, dy by dx equal to s ped minus se divided by 1 minus Froude number square. I hope you have derived this equation. Have you remembered? The same. This is the same equation.
Yes, sir.
This equation we have derived, just it is in this format, dh by dx format. It is, we have taken as a y as a depth, here they have taken as a h as a depth. Okay, same equation we have derived. So here just I am highlighting, but this is very useful next to decide the surface profile. As we know dy by dx, you all know the dy by dx, if it is equal to 0, can anyone tell what type of flow you get?
Uniform.
Yes, if dy by dx is less than 0, or you can take it as a negative, what you get? What type of surface you get?
Drop down.
Drop down. Drop down. If dy by dx is greater than 0 or positive, yes,
Backwater,
Backwater curve.
backwater curve.
yes, backwater curve. If you know this much, then you can easily understand the water surface profile. Next, what I am going to discuss. So here, dh by dx, or you can take as a dy by dx. So in our discussion, we have taken it as a dy by dx or dh by dx, both are same only. Here, if dy by dx or dh by dx is a positive, the depth is increasing along the direction of flow. If it is negative, it means it is decreasing along the direction of flow. Or if it is equal to 0, it means it is a normal depth flow or uniform flow. I hope you all understood.
Yes, sir.
Okay, just comment in comment box, all of you, whether you understood this dy by dx term or this equation what we derived for the gradually varied flow. I hope you all of you understood the equation, what it means, the positive, negative, or equal to 0. Just comment in comment box, I'll check in comment. I hope you understood, all of you. Because next what I am going to classify the channel bottom slopes or classification of water surface profiles, it entirely depends upon the dy by dx. Okay, okay, right. Now coming to the this one, this is very important. The next part of this chapter is this one is types of channel slopes. Okay, so as you all know, when the water will be flowing in a channel, but depending upon the slope of the channel, the channel bottom can be classified as mild mild slope channel, steep slope channel, critical slope channel, even we are having a horizontal channel slope, adverse channel slope. So there are different types of slopes we get depending on the depth of the flow in the channel. Okay, depending upon the depth of flow in the channel, so we'll be having different kinds of slope of channel here. So what mild slope means? The mild slope is one on which uniform flow is subcritical. A mild slope is one on which the uniform flow is subcritical. So what are the conditions for the mild slope? Just look at this condition. So what this condition is giving here? So the mild slope is represented by M. M means mild slope. You all can see the picture of this channel here. You all can see here. And here YO and YC is taken. What is YO means? YO, or you can take it as a YN. It is a normal depth flow. You can take it as a YN also. Sometimes it will be taken as a YN also. YO or YN means the normal depth flow. YC is the critical depth. And SO, or sometimes in some of the textbook they are taken as the SB. That is also correct. Means the channel bed slope. Here they are taken as a SO. And SC means the critical channel bed slope. Critical channel bed slope. And based on the depth of flow, that is a normal depth of flow, critical depth of flow, the channel bottoms can be classified as a mild slope, is one on which uniform flow is subcritical. The condition is what? The normal depth of flow should be greater than the critical depth. You all know, based on the Froude number, so if Froude number is greater than 1, what kind of flow you get? Yes, tell me. I'm writing it. If Froude number is greater than 1, what kind of flow you get?
Sir, supercritical.
Supercritical flow you get. Means supercritical flow means the depth should be lesser than the critical, right? Yes or no? Y should be less than YC? Yes or no?
Yes, sir.
If Y is greater than YC, means depth of flow in a channel is greater than YC, is it a subcritical flow, right? Then for that we get as a less than 1, right? Are you getting my point, all of you? Then
Yes, sir.
if Y equal to YC, it means the Froude number equal to 1, we get as a critical flow. So based on this depth of flow, that is a normal depth of flow as well as a critical depth of flow, the relative positions, the channel bottom slope can be classified as a mild slope for the condition. You have to remember the condition. The normal depth of flow should be greater than YC, or the bed slope of the channel should be less than the critical slope of the channel. These are the conditions. For this, if the channel is satisfying these conditions, then that channel is called as a mild slope channel. It is represented as a M. I hope it's clear to you all. Then steep slope. The steep slope means the water will be flowing very fast. For the steep slope, a steep slope is one on which uniform flow is supercritical. Then coming to supercritical, what is the condition for the supercritical? What is the condition for supercritical? Hello?
Sir, Y naught is less than YC.
Y naught should be less than YC. So it is given here. Just look here. Okay. It means for a steeper slope, the flow will be very fast. and that flow is called as a supercritical flow. For that, the Froude number will be greater than 1. The condition is what? Y naught is less than Yc, or you can take it as a Y is less than Yc. And bed slope, that is the slope of the channel, should be greater than the critical slope. Okay. Then critical slope is one on which the uniform flow is critical. So this is the critical one. So here it is mentioned here, or here it is mentioned here, critical slope. So this is the condition for the critical slope. Y naught is equal to Yc, or S naught equal to Sc. Okay. So let Y naught and Yc designated here the uniform and the critical depth for the given discharge Q respectively. Then we can write mild slope means Y naught is greater than Yc, steep slope means Y naught is less than Yc, and critical slope means Y naught is equal to Yc. Then the classification of the slope will depend on the roughness, on the magnitude of the slope itself, and to lesser extent on the discharge. Same slope depending on the roughness of the channel bottom can be mild, critical, or steep. Okay, so you have to remember the conditions here. Based on these conditions, the slopes can be, the channel bottom slope can be classified as a mild slope, critical slope, and as well as the steep slope. Okay. Then coming to here, recalling the definition for the normal depth yn or y and the critical depth yc, the following inequalities can be stated. When SF means the energy gradient line, this is SF. Okay, if energy slope of energy gradient line is greater than the slope of bed, so it means the y will be less than yn. If slope of energy gradient line is less than SO means the bed slope. When y is greater than yn. If Froude number is greater than 1 means when y is less than yc. When Froude number is less than 1 means when y is greater than yc. Means it is a supercritical flow, it is a subcritical flow. And coming to the different slopes here, a gradually varied flow profile is classified based on the channel slope and the magnitude of the flow depth y in relation to yn and yc. The channel slope is classified based on the relative magnitudes of the normal depth and the critical depth yc. Okay, so you have to check the normal depth first, and also as well as the critical depth to be calculated by using the Froude number and all, or the equations, whatever equations you are having, you calculate the critical depth. With respect to the critical depth, you calculate the other depths, then you compare the two values of the depth of flow, then decide what kind of slope it is, whether it is a mild slope, steep slope, critical slope, horizontal slope, or adverse slope. For each one of the slope, there is a condition. So what is the condition for the mild slope? The normal depth of flow should be greater than what? Critical. I hope you are understanding, all of you.
Yes, sir.
Yes, sir.
See, the condition is very important. In if they ask, give the classification of the channel bottom slopes, then you have to write mild slope, steep slope, then you have to write the conditions. See the depth of flow here I have mentioned here. Look at the figure here. So I hope you all can see this figure, right? This one, first one. You all can see this one.
Yes, sir.
So this line, the red line, what I'm highlighting here, it is the depth of flow, but critical depth. But actual depth is how much? YO. YO, that is Y naught is greater than YC or less than YC.
Greater than YC.
So it is a greater than YC. Means the water, the depth of flow in the channel is flowing greater than the critical depth. At the same time, the bottom slope of the channel is less than the energy gradient line. See, one more condition here as they are having. Okay, and for these conditions, the slope will be mild slope, M. Okay. If suppose reverse, if Yn is less than Yc, means Yc is here, but Yn is here or Yo is here, means the depth of flow is very less, means it will be flowing with very fast, means as you all know, velocity is inversely proportional to depth of flow. Correct? Huh? If depth of flow is less, velocity is more or less?
More, sir.
More. If depth of flow is high, what about velocity?
Less.
Less. Just look at these two figures, figure A and figure B. In first case, the slope was very mild, where the velocity of flow was less than that velocity we call as a subcritical velocity. For the condition is what? Yn is greater than Yc, and it gives you the mild slope. And in second case, the steep slope is the water will be flowing very fast. For that case, the Y will be less than Yc, that is, it is flowing with a critical flow depth, and it is represented as a steep slope. For the condition is what? The slope of channel bottom is greater than the slope of the energy gradient line. Whatever the gradient line you are getting here, it is the slope of the bed slope will be, that is, the bed of the channel will be more. That is a condition. Then critical slope, when we get a critical slope, when the depth, both the depth, critical as well as the flow depth or the normal depth, both are equal, then that time what we get? Critical slope. I hope you understood. At that
Yes.
time, the slope of the bed channel as well as the slope of the energy line will be equal. Is it clear?
Yes, sir.
All of you understood M, S, C slope. M means mild slope. S means steep slope. C means critical slope. So what is the condition for the critical slope?
Yn equal to Yc.
And as at the same time, this is the condition. Bed slope of the channel is equal to the bed slope of the energy gradient line. Okay. Similarly, horizontal slope. Horizontal means perfectly horizontal. There is no slope at all. The bed slope will be 0. And at the same time, what about the depth of flow will be critical? Is it clear?
Yes, sir.
That is the horizontal slope. Then the adverse slope. It is important here. Adverse slope. When you get the adverse slope, when the slope of the bed is less than 0, means it is reverse. It is in increasing. The bed slope is increasing in this direction. When it is increasing in this direction, is it a negative value, right?
Yes, sir.
It's a negative. Then the bed slope of the channel will be 0. That's why I told the dy by dx, you have to remember dy by dx equal to 0. It means what type of flow you get? It's a perfectly horizontal, right? Is it clear? If dy by dx is greater than 0, what type of flow you get? Backwater. If dy by dx is less than 0, what type of flow you get?
Drop down.
Drop down. Okay. So those things to be remembered, but here the channel bottom slopes you have to remember based on the depth of flow with respect to the critical flow. So remember these conditions, all of you. Mild slope, the y should be greater than yc. But steep slope, y this should be less than yc. Critical slope, y should be equal to yc. And horizontal slope, the bed of the channel should be equal to 0, and the flow depth will be critical. Adverse slope, the bed slope is negative, or it is in increasing order along the direction of flow, and the depth will be critical. Is it clear?
Yes, sir.
For all, I'm asking, how many types of bed slopes are there? How many types? How many are there? Hello? How many bed slopes are there?
5.
5. What are those? What are those? Mild slope is represented as a M. Steep slope S. Critical slope C. Horizontal slope H. Adverse slope A. And for each one, this is the condition. See the conditions here. It is very important to understand what type of slope you are having. Okay. Then coming to here, water surface profiles. So if you take the number 1, the channel category is the mild slope. If it is a mild slope, what is the symbol for the mild slope? M. So likewise, only you have to write in exam. I hope you are getting or understanding what I am saying. If they asked, just give the water surface profiles classification, then you would write like this: mild slope. Mild slope, what is the symbol for the mild slope?
M.
M. Characteristic condition is what? Y should be greater than Yc. And what type of flow it gives? mild slope, what type of flow it gives?
Subcritical flow.
Subcritical flow, because the depth of flow is more than the critical. Subcritical flow at the normal depth. Then suppose steep slope. What is the symbol for the steep slope?
S.
Yes. What is the condition?
IC should be greater than 1.
Yes. What kind of flow you get?
Supercritical flow.
Yes. So same. Similarly, critical slope. Its symbol is C. The depth of flow in a channel. You can look at here. There is a picture here. It is given the conditions. So YC is equal to YO, critical flow at the normal depth. Horizontal bed H, the bed slope is 0, cannot sustain uniform flow here, horizontal flow. And adverse slope again, its symbol is A. It is yes, but its bed slope is less than 0, means it is in increasing in this direction. It is a negative, cannot sustain the uniform flow. Okay, so these are the some water surface profile classifications. Then coming to this one, water surface profile classification, how the water surface profile can be divided into a different zones, how it can be understood. See, the flow profiles associated with, as we discussed previously, there are different types of that is the channel bottom slopes. As we have discussed, the mild, steep, critical, horizontal, and adverse slopes. These all are the channel bottom slopes. And depending upon these channel bottom slopes, the water surface profile can be classified. Okay, so here for each one of the channel bottom slope, that is for the mild, it is represented as a M. For the steep, it is represented as S. For the critical, it is represented as C. For horizontal, it is represented as H. And for the adverse slopes, it is represented as A profiles respectively. Suppose if they are mentioned in a M, it means what? Mild slope. If they mentioned a S, what kind of slope it is?
Steep.
Steep. If they mentioned A, what kind of slope it is?
Adverse.
If they mentioned C,
Critical.
critical. H,
Horizontal.
horizontal. You have to remember the symbols. M means mild, S means steep, C means critical, H means horizontal, and A means adverse respectively. Okay, then so with respect to that, the space above the channel bed means above the channel bed, this is the channel bed. So above the channel bed, the entire zone is divided into 3 zones, or the entire space is divided into 3 zones, that is zone 1, zone 2, zone 3. Then we will discuss about what is this zone 1, zone 2, zone 3 for the flow. So the space above the channel bed can be divided into 3 zones depending upon the inequalities defined by the equations. So from the equation, you should get whether the flow is in zone 1 or zone 2, zone 3. Okay. The zone 1 means what? The space above the topmost line. So here we are having a 2 lines, one for the critical depth flow. The one line will be critical depth. So it is represented as a YC, and other depth is YN, that is normal depth. This is YO, means the critical flow could be here or it could be here also, anywhere it may be. It depends, and how you means what value you are getting. It could be lying here also, or it could be lying here also. That's why it is mentioned here. The critical depth of flow may up to here, or it may be here also. So depending upon these two positions, suppose if Y is greater than YO, means YO, whatever the flow you are getting, means suppose this is the depth of flow Y I am taking here. This is the depth of flow is here. I hope you're understanding. I hope you're understanding, all of you. The zone 1 is lying above the 2 lines. Means above the 2 line means one line is for the critical depth, other one line is for the normal depth. You can call it as a normal depth line, and you can call this as a CDL, critical depth line. I am mentioning here CDL. CDL means what?
Critical depth line.
Yes, NDL means what?
Normal depth line.
Okay. This is the 2 depths what we are getting in a channel. Suppose if you are allowing water to flow in a channel, but it is lying above the normal depth line, means this is above the both 2 lines, yes or no? NDL and CDL. Are you getting my point?
Yes, sir.
this flow depth is above the both. Above both means CDL as well as NDL above. So it is lying in a zone 1, right?
Yes, sir.
So I can write if Y is greater than YO or YN, which is greater than YC, and also if Y is greater than YC or greater than Yn, it is called as a zone 1 flow. It is lying in a zone 1. Are you getting my point? If
Yes, sir.
suppose depth of flow is lying here, it will coming in zone 1. Zone 1 means it is above both. Above both means CDL as well as NDL. CDL means
Critical depth line.
NDL means
Normal depth line.
yes, remember. Now, suppose zone 2 means if it is lying between these two, means NDL and CDL. Zone 2 is what? The space between the top line as well as the next lower line. The top line means NDL, next lower line means CDL. If it is lying between these two, it is called as a zone 2. For the zone 2 condition is what? Suppose for the zone 2, if suppose the water depth is here, just I'll erase this one. Suppose, okay. Suppose the depth of flow is here. Here, my depth of flow is here. I hope you all can see this, what I am writing here. I hope it is it visible?
Yes, sir.
See, now my depth of flow is here. Is it more than YC or less than YC? This second one, what I am mentioning here, Y, is it more than YC or less than YC?
Sir, less than.
Means you compare this one, sorry, this one. This is YC and this is normal depth. Here is a normal depth. This is YC. Is it above the YC, right?
Yes, sir.
Yes, sir.
If it's above YC, it means if Y is less than Yn, means this is Yn, that is normal depth. This Y, whatever I am taken this one, which is lesser than the Yn and greater than the YC, correct? Whatever the depth getting, which is greater than YC, but Y is less than Yn, right? Yes or no?
Yes, sir.
So that zone is what we call as a zone 2. Zone 2. It is between NDL and CDL. Zone 3 means the space between the second line and the bed. Means from the bed, if you take the between these two, it will be zone 3. So zone 3 condition is what? Suppose the depth of flow is here. Y is here. Tell me Y is here. Means Y will be less than YC, right?
Yes, sir.
Y will be less than YC. And also Y will be less than Yn also, correct? Understood? Means it is this Y is below the both normal as well as the critical. So this zone flow would what we call as zone 3 flow. Understood all of you?
Yes, sir.
Zone 1 means where it is lying?
Above NDL and CDL.
Yes, above NDL and CDL. Zone 2 where it is lying?
Between NDL and CDL, sir.
Yes. Zone 3 where it is lying?
Below CDL.
Yes, it is between the bed of the channel as well as the CDL. I hope you all of you understood. But you have to remember the depth of flow with respect to the critical as well as the normal depth of flow. Normal depth of line. This is a normal depth line and this is the critical depth line. So apart from these two, if the depth of flow is here, why? Or it could be here or it could be here. And compare with respect to the critical as well as the normal depth line. And according to that, you mention whether it is lying in a zone 1 or zone 2 or zone 3. I hope you understood all of you.
Yes, sir.
So please write in a comment box of if you understood all of you. Just mention. Okay, good. Then coming to the next one. So the same here. profile classification. Again, profile classification, the same. So what I explained previously, the profile classification here. Again, the zone 1, here I mentioned zone 1, zone 2, zone 3. And this topmost line is called as a normal depth line. And the middle line is called as a critical depth line. And the bottom line is called as a bed of the channel. Okay, so it is mild channel here. So let us understand about the mild channel here. The space above both the CDL or NDL, the space above both the CDL or NDL, whichever is upper, is designated as zone 1. Means sometimes the CDL could be here. Means it sometimes the CDL could be above or NDL could be here. I hope you're understanding what I'm saying.
Yes, sir.
Sometimes the critical depth of flow may be here, the line, or it may be here, the NDL. Okay, that is I mentioned. The space above both the CDL or NDL, whichever is upper, is designated as zone 1. So above CDL and NDL, whatever the zone is lying, it is called as a zone 1. And the space between the CDL and the NDL is designated as zone 2. This is a zone 2. This is between CDL and NDL. And the space between the channel bed and CDL or NDL, whichever is lower, is designated as zone 3. Means thus if the CDL is lying here, then we can call it as is the zone, the space between the bed and the CDL. Or if it is the NDL is lying here, then we can call it as the space between the NDL and CDL, like this. Okay, then that is called as zone 3. I hope you understood, all of you.
Yes, sir.
So it is same for all mild channel, steep channel. It is to be divided into 3 zones. Zone 1, zone 2, zone 3. Zone 1 means above CDL and NDL. Zone 2 means between CDL and NDL. And zone 3 means it is between the bed of the channel or CDL or NDL. Is it clear?
Yes, sir.
Okay. Then coming to the designation of the flow profile. The flow profiles are finally classified based on the channel slope, as we discussed previously. That is a mild slope, steep slope, critical slope, horizontal slope, adverse slope, like this. The channel, that is a flow profiles, can be classified based on the channel slope. And the zone in which they occur, means the zone 1, zone 2, zone 3, like this, they are to be designated. So for example, how the profile can be designated is a very important. When you have studied the slope of the channel as well as the profile of the water surface, in which zone it is lying, that is zone 1, zone 2, zone 3, like this. For example, try to understand it here is carefully. If the water surface lies in a zone 1, suppose the water surface is lying in a zone 1. Zone 1 means where it is?
Above NDL and CDL.
Above NDL and CDL, zone 1. Okay, suppose in a channel with a mild slope, the slope is mild, it is designated as M1. So what M indicates here?
Mild slope.
Mild. What 1 indicates?
Zone 1.
Yes, like that it is to be designated the surface of the water. So I'll repeat, for example, I'll repeat once again. The flow profiles are finally classified based on the channel slope, that is channel bed slope, the zone in which they occur. For example, if the water surface lies in zone 1 in a channel with a mild slope, it is designated as M1 profile. Here M stands for the mild channel and 1 stands for the zone 1. So this is the channel which the water is flowing. See, look at the channel. This is the water is flowing. This is the bed of the channel. So this is the bed. And then you calculate the critical depth. You have equations to calculate the critical depth and all. And according to that you calculate, then the critical depth is lying at this distance. Let us call this as a YC. I am calling it as a YC, critical depth. And also the normal depth line is lying here, YN. And actually the depth of water here lying, actually it is lying here. And above both, above critical as well as the normal depth. So it is flowing like this, means the depth of water actually lying is above critical as well as the normal depth. So which is giving the mild slope like this. And this type of profile, for this type of profile, what we get, what kind of flow we are getting is subcritical flow. I hope you understood, all of you, because it is more than the critical, right? Depth of flow is more than critical. Is it clear?
Sir.
This is called mild slope profile. M means mild slope. 1 means it is lying in a zone 1. Is it clear?
Yes, sir.
This is M1 profile. So with likewise, you can classify the various, means M1, S1, A1, like this. Means different types of slopes you are having, and according to that you can classify. So look at this one. I have classified here: channel slope, profile notation, flow depth, dy by dx, type of profile, type of flow. So this chart should be remembered, all of you. Okay. For the mild slope, what is the designation for the mild slope? It is M. Designation is M. M means mild slope. If suppose M1, M1 means what? M1 means
Mild
what?
mild slope in zone 1.
As mild slope, but it is in zone 1. What is the condition? Y should be greater than Yn and also greater than Yc. Is it clear?
Yes, sir.
And again, if you take the dy by dx, it should be more than 0, means positive. Understood?
Yes, sir.
Is it a backwater curve or drop down type of profile?
Backwater curve.
Backwater. What kind of flow you get? Type of flow.
Subcritical.
Yes, look at this picture here. The water is rising in the direction of flow. If it is rising in the direction of flow, it means the depth is increasing. If the depth is increasing, means is it a backwater, right?
Yes, sir.
And we get a positive, right? Dy by dx is a positive, right?
Yes, sir.
All of you agree for this one?
Yes, sir.
Is it a positive? So likewise, if you take a M2 curve, M2 curve means the YC should be less than Y, means the critical depth should be less than Y, but Y should be less than Yn. Means if you take, it may be lying here. The depth may be lying here. I hope you're understanding. Y should be here, but critical depth is here. So the Y is greater than YC, but less than the Yn. Is it clear? Is it clear? This one. And it should be less than 0. What type of flow you get? What type of flow you get?
Drawdown.
That is, type of profile is drop down and the type of flow is subcritical. So likewise, you can take the others, M3. Okay, M3, where Y is less than YC, means we get as a critical flow, supercritical flow. And dy by dx is greater than 0 also. And backwater curve we get for the supercritical. And similarly for the steep slope, if you take a steep slope, again it is S1, S2, S3. S is the steep, 1 means the zone 1, zone 2, zone 3, like this. And similarly for the other critical slope and horizontal slope and the adverse slope. So please study this chart given here for all. So you can take the snapshot of this chart, all of you, and please study this one. Likewise, how we are studied for the mild slope. Likewise, you study the steep slope. Condition for the steep slope, you study it. And dy by dx equation, as you know, for the gradually varied flow equation. And there are two types of profiles, as you know, drop down or backwater. Drop down means it is decreasing or increasing. Decreasing curve or increasing curve.
Sir, decreasing.
Backwater means
Increasing.
that
Increasing,
much
sir.
you remember. That much you remember. If dy by dx is a positive, means increasing. Negative means
Decreasing.
yes. That much you remember, and according to that you classify this channel. That is a flow profiles. Please take this chart and study it. Okay. Shall I go to the next slide? I hope you all have taken this snapshot. I'll share this PPT also, but you study it. Okay. So coming to the next one, the variation of flow depths. So qualitative observations about the various types of water surface profiles can be made and the profile can be sketched. See here, qualitative observations about the various types of water surface profiles can be made and the profile can be sketched without performing any computations. Okay, so you can by looking at the depth of flow, you can sketch the profiles directly. So this is achieved by considering the signs of numerator. Means the signs of numerator means this dy by dx, dy by dx. What is the equation? Can tell me fast? SB minus SE 1 minus fast
R square.
FR square. Okay, based on this equation here, this is achieved by considering the signs of the numerator and the denominator in equation. Means if we are getting a negative, as you all know, we get a drawdown curve. If we are getting a positive, we get as a what is that backwater curve. The following analysis helps to know whether the depth is increases or decreases with the distance and the profile approaches the upstream and the downstream limits. So from this equation, whatever positive or negative value we're getting, so we can understood from that whether the depth is increasing or decreasing with the distance, and also how the profile approaches the upstream and downstream. We will come to know from the positive and negative values. Is it clear?
Yes.
Is it clear? Okay. So again, the same as I mentioned here. So if y is greater than yc, the flow is subcritical. The Froude number will be less than 1. Is for this one, the denominator is positive. Look at this one. This equation I am given here. SO or SB, whatever you can take it as, you can take it as a SB or SO, that is a bed slope, or it is SF means, or SE means the slope of the energy line 1 minus FR square. So here also given SO minus SF 1 minus FR square. Suppose if you are getting both positive, this also positive, this also positive, what you get the dy by dx?
Positive.
Positive. Suppose if SO minus SF, if you are getting a negative above numerator, and the denominator if you get a positive, what you get dy by dx?
Negative, sir.
Negative. If you are getting a numerator negative, denominator negative, what you get?
Positive.
Positive. So like this, the same I given here. If y is greater than yc, the flow is subcritical. F is less than 1, it means the denominator is positive. For that you are getting a subcritical flow, which is the flow will be like this. It means it is a backwater curve, means the water will depth will be rising. Suppose y is less than yc, the flow is supercritical. Froude number is 1, denominator is negative. If denominator is negative, what you get here? If the denominator is negative, you will be getting negative or positive, any one you will get. And for that, either you may get the drawdown or you may get the backwater curve. If y equal to yn, flow is uniform. SF equal to S0, the numerator will be 0. Here the numerator will be 0. Look at this equation and just study. Y equal to yn, flow is uniform. SF equal to SO. When SF equal to SO means this term equal to 0, you will get the numerator is 0. If y is greater than yn and the slope of energy line is less than bed slope, numerator is positive. When the numerator is positive, then again you will be get dy by dx as a you will just check out the denominator also at that time. Then according to that you have to decide dy by dx was it positive or negative. And if y is less than yn, SF is greater than SO, numerator is negative. So for these conditions, just numerator positive or denominator positive, they are giving here. Whether the numerator will become a positive or denominator will be a positive, or numerator will become a negative or denominator will be negative. So based on the depth of flow, you can decide. I hope is it clear?
Yes, sir.
For all I am asking, just give me the comment box. Just let me check. I hope you all of you understood the profiles at least. Just give a comment. It's very simple. If you go through this, you can easily understand positive, negative, positive, negative. Positive means upward, negative means downward, that is a drawdown curve, as well as the backwater curve you will get. But as you go on solving the problem, you can easily understand how to draw the profiles and all. It's a very simple and sure question. You will in exam give the classification of water profiles in all the question paper you take. This question has arisen. Okay, this question is being asked. Okay, please study it well. Okay, right. Then coming to the after this one, here, so very important again. uh, for a given discharge, and n means Manning's constant, n means the Manning's constant, or you can take it as Church's constant, and bed of the channel, y is uniform flow depth, yc is the critical flow depth, y is the uniform flow depth. Suppose if you are taking y as the critical uniform flow depth, or you can take as a yn as a uniform flow depth, and yc is the critical flow depth, and y is the non-uniform flow depth, means yn is taken as a uniform flow depth or the normal depth, yc is the critical depth, and y is the variable depth. The depth y is measured vertically from the channel bottom. The slope of the water surface dy by dx is relative to this channel bottom. Means there is a channel here, then the water is flowing in this channel, and we have considered both lines, CDL critical line as well as NDL. I hope you are understanding. NDL means what? Normal depth line as well as a critical depth line with respect to this. So in between there is a depth, one more depth of flow, that is a non-uniform depth of flow which is flowing. Suppose if this vertical, that is dy by dx, is infinite, means it will be a vertical like this, or else. So one more type here, look at this one, the channel is like this. If suppose dy by dx, just a minute, here, suppose if the dy by dx is less than 0, if dy by dx is less than 0, how the approaching of the flow will be? Downward. I hope you are getting, it is coming down, right?
Yes, sir.
Suppose dy by dx is greater than 0, it is moving in this way. Is it going up, right?
Yes, sir.
If dy by dx is less than 0, it is coming down. If dy by dx is going greater than 0, means it's going up. If suppose dy by dx is equal to 0, means it will be flowing with a normal depth like this. Is it clear?
Yes, sir.
Right. Okay, the prediction of the surface profile from the analysis, means from this equation we can predict whether it is a drawdown or whether it is a backwater curve. We can predict from this one. Okay, and suppose if dy by dx, as I said, if it is equal to 0, we get as a normal depth flow or uniform flow depth. If dy by dx is less than 0, we get as a drawdown. If dy by dx is greater than 0, we get as a rising, means backwater curve we get like this. Suppose if this numerator becomes a 0, when numerator becomes a 0, we get dy by dx as a infinite, right?
Yes, sir.
We get the value of dy by dx is infinite, means we cannot predict where the depth of flow will be. I hope you're understanding. It's just an imaginary depth. Is it? I hope you understood, all of you.
Yes, sir.
The depth of flow will become just imaginary. We cannot get practically. It's just an imaginary, right? Is it clear?
Yes, sir.
If dy by dx is infinite, okay. These are the surface profile classification. Again, same, the water surface profiles classification is been classified here. So again, about these things again we'll discuss in the next class. I hope this much you understood, all of you, till here. Is it clear?
Yes, sir.
Okay, this is there for your internal. It is a very important, And water surface profiles, how it has been classified, what are the different what channel bottom slopes, that is there are 5 types of slopes: mild, steep, critical, horizontal, adverse. Like this you have to classify it. So here you please make a notes of it. Okay. Also what are the practical application, means practical where you generally come across like this. So here I given that is the flow behind the dam, what kind of flow profile you may get. Or you take this one, this is the various examples here I given. So here the flow behind the dam, the mild slope we get, then the flow over the drop, the M2 slope, then the flow under the sluice gate, M3 slope. So you may check it. Okay. The flow behind the dam, if it is lying, the depth of flow is lying below the critical, it will be like this. Then you will get the S1 slope, S2 slope is like this. There are various kinds of slope you get. How the flow profile should be behind the dam, or under the sluice gate, or over the drop. So you may sketch the profiles based on the dy by dx equation and all. So these are the profiles. Okay. So these are the things. So with this you are the module get over. So anyway, tomorrow also I'll take a one class regarding this profiles. So then this module get over. Is it clear?
Yes, sir.
Okay. Right, I'll wind up the today's session here. I hope you understood, and your internals will be on 3rd, right?